Go.
Okay, welcome to Rena's HPLC Master Class. So today we're going to be replacing a column. So in order to store it, we're going to be following the use and care manual or care and use manual on how to actually store this current column when we want to take it off. Pretend that we're flushing the column for the C18 or just removing the C18, which here is the X-Bridge fennel column that I'm just using working with my mini experiment, which I'll talk about later in the presentation. But with this one, so you would disconnect it and then you would place it into a beaker and let it drain out first so it can just rinse itself out, and then you would store it in 100% acetonitrile. That just maintains the, consistency and quality of the column, and so you could just be able to flush it again and put it back on the column, and it wouldn't be damaging while it's in storage. So we're just going to pretend that this column would be set up like this, and so you can see the arrow, that's the flow path, so you want it to go from the pump up to the detector. So you would remove these top pieces and then you would put this red wiring facing down into the beaker, and then you would increase the flow from like 0.1 mil to 0.5 mil across 5 minutes, and that would just allow for that to cycle through the column and wash it out. Okay, so we're here draining the column and we just want to stop the flow once we've completed that portion, and we'll put it into our storage, our 100% acetonitrile, and then this is where we can put on the X-Bridge column, the fennel column. Go ahead. Okay, so now we want to work with our new column, which would be the X-Bridge fennel column as we see here. So if we want to install it, we first want to stop the flow. It already is at 0 because it's on idle at this point in time, but assuming that it is running or you're running a previous washing through the column, then you want to be able to stop the flow, and this is where you can actually start draining your new column. So you can remove this. If I can remove it, cut it. So now we're at the step, we have removed our old column, and we flushed the previous one, we stored it in the acetonitrile, and now we can stop the flow. So before you try to remove anything, it's always best practice to just stop the flow. And so we have now stopped the flow, attached this column here, and what we would do is run it into a beaker off the side like this, and we'll do our initial flush. So we'll go from like 0.1 ml to 1 ml across 5 minutes. This would be our initial flush. It just depends on the specific column. You can also see this in the care and use manual. Water's care and use manual is the Bible. And now, once we have done this flush, we can stop the flow. Okay, so now that we have done that equilibration or the initial flush, we stop the flow, then we can attach this bottom or this top piece. See the flow is going up to the detector, or you can see it here on this engraved arrow going up to the detector. So we're just gonna twist in this ferrule. You want to make sure that you're maintaining pushing it down as you screw it in. I feel like I'm screwing it down. Okay. We're getting there. And then we can push it in, making sure that the wiring isn't weird. Line these up. These move, just so you know. You guys already know. And now we can do our column equilibration. So based off of the care and use manual, you can find the empty column volume, which would be the 2.5 ml. It's based off of the dimensions you can see here. So this is the X-Bridge column. So you have the 4.6, which is going to be the diameter, the 150 millimeter, which is going to be the length. So this determines your empty column volume, which is going to be 2.5 ml, and then you want to multiply that by 10. And so this will be the amount of volume that we minimally want to equilibrate with the column. And if our flow rate is 1 ml per minute, then, because also anything higher with this column will create a lot of back pressure and possibly cause leaks. But if our flow rate is 1 flow a minute and it's 25 mLs, then it's going to take 25 minutes to equilibrate this column with the HPLC and with the instrument. Okay, so now our column is installed onto the instrument. So we just want to wet prime. I'll go into this later, or maybe I've already talked about it in the presentation. Just wet prime is a good practice when you install anything new, or just to remove any air from the system. And in this case, like, we had the flow stop, but just in case, it's a good practice to just wet prime everything, push that air out. And so we'll wet prime our column, and then we can do a blank injection and a standard injection just to see how the column is operating, see if anything changed. This is just a part of the system suitability. We also want to keep track of our plate count. So our theoretical plate count ties into the column efficiency, and it's just like the filtration process within the column. And over time, these might degrade through just normal wear and tear, and that's just like a direct way to keep track of our column efficiency and know when we need to replace the column. So this just goes into replacing it, and we have our new column on there.